Hola, soy Brendan. Do you want the map to DevOps success without the risk of anyone swiping results from you? Then you're in the right place. And don't worry, that is the last of the Dora the Explorer references, I promise. But I do want to explore Dora with you today. And I'm not talking about the Nickelodeon character. I'm talking about something that my kids are way less interested in, but something that I hope you are way more interested in. DORA is the DevOps Research and Assessment Group, a group founded by Dr. Nicole Forsgren and Gene Kim to conduct academic-style research on DevOps and how organizations were implementing it throughout their software delivery organizations, to try and understand what makes for a great DevOps transformation. Basically, if we, people like me, standing on stage and saying DevOps is great, everyone should be a DevOps, while many others in industry are still struggling with understanding how dev and ops fit together and what that means for agile or the future of software in general. How can we provide a happy path, a known map to distinguish those groups who see success with DevOps from those who aren't quite there yet? If we had this map, we could apply it to our own DevOps journeys and be able to say, Excelente, we did it. We did it. Okay, seriously, that is the last Dora the Explorer joke, I promise. Like every good journey, I want to start at the beginning. I want to go back to when DevOps was in its infancy, at a time when I was running product and engineering at a small medical software company. And one day there, I was walking back to my office from the CEO's office. I don't remember what the meeting in the office was about, but it ended up being a lot less important than the other lesson I learned on the way back to mine. Here you can see this highly accurate map that I made of the office. Look, I'm clearly not a graphic designer. That's why I learned how to code instead. But it still helps illustrate the point. Between the CEO's office and mine was the server room. Do you remember those? We used to have these big rooms where we put big air conditioners in and these things that were actually called offices that we used to have. Well, that's a story for another day. But on this day, I'm walking past the server room and the door is propped open. That is never a good sign. That door is almost never open, right? So as I walk past, I look to the left into the room where the desk is at the other side of that room. That's kind of the work surface area. And there, sitting with a server on their lap, is one of our lead developers on a new product that we were working on bringing to market. And they have a screwdriver stuck into the server, getting a hard drive out. It turns out that was the Redmine server, the tool we used to track all of the work we were doing and the plans for the product. It had a hard drive fail, and the developer didn't know what to work on next. So instead of coding, they were fixing the server. And I had an epiphany in that moment about something that economists like to call opportunity cost. We were working on getting a new product to market, a modernization of our existing product line, to be the first to bring tablet-based questionnaires to market in our limited vertical. And here was the lead developer for that project, the architect really, with a screwdriver and a server. We were paying them to develop the software for our customers, but their time was being spent on a Redmine server. The next day, I took my corporate card, the one with my name on it, at a company that was not venture-backed and was very conservative about spending money, and I started paying for tools, ones we didn't have to stick screwdrivers into. I wanted my engineering team to be able to spend their time doing engineering work for our customers. People thought I was crazy for spending this kind of money, but I knew that it was all leveraged, getting our team back to work on the things that they and I wanted them to be working on. This example may be from long ago, probably 10, 15 years at this point, but I always find myself coming back to it because there's still a lot of time we spend with screwdrivers in computers, though maybe not always literally. Time in the AWS console, that might as well be a screwdriver. What about time spent on moving software between different tools, on waiting for CI to finish, or on doubling back when a security problem is discovered too late in the review process? What is that time spent? And you may be saying to yourself, so what? Like, especially if you haven't spent a lot of time experiencing this pain directly. But I postulate that this is the number one thing that business leaders and engineers should be thinking and talking about. Famously, the venture capitalist Mark Andreessen was quoted as saying software is eating the world. Well, in this time where we order our actual food from an app and then document it by taking a picture of it with another app, I think we can safely say that software has in fact eaten the world. And in this world, the businesses that are able to survive and thrive are those who can quickly adapt to changes in their markets, the macro economy, or the world as a whole. And the way that businesses adapt quickly today is through software. And that's why more recently, Andreessen was quoted as saying that cycle time, that is the time from idea to production or concept to cash, is the most underestimated force in determining winners and losers in tech. And those winners and losers in tech will determine winners and losers in every industry. Every company is a software company, and their ability to ship better software faster is the thing that will determine if they win or lose in their respective markets. But wait a second, Brendan. I hear a lot of you saying, it surely isn't all about speed. Going faster isn't the only thing. You can't just go fast and break things. And to some extent, you're right. Not only do we have to be concerned about speed, about how fast we can deliver products to market, and how quickly we can then adapt those products to match changing market conditions, we also have to think about the stability of our product and our platforms that we put out there. Our customers will only stay our customers if we're able to provide them with a stable and reliable product, one that they can count on to be there, one that is secure and safe. And oftentimes in the technology world, we see these two forces as out of sync. Our intuition, our traditions, our preconceptions of what it means to deliver secure, stable products make us say and think, oh, well, the way to keep a system stable is to slow down. More changes will only serve to destabilize any systems, so we have to resist the urge to move faster for the sake of stability. But I'm here to tell you without any reservations that that is completely incorrect. This is one of those cases in life, which I guess there aren't many of, where you can have your cake and eat it too. In fact, not only do the top performers in terms of software delivery operations excel in both speed and stability, there is actually a positive predictive relationship between speed and stability. Now, that's kind of a bold statement, so how do I know that? Well, that's where our friends at DORA come in. They've been doing research for over 7 years at this point, applying complex statistical analysis to data collected from thousands and thousands of organizations to be able to draw meaningful conclusions from that data, identify patterns in it, and create models that can then aid organizations of any size to know what to focus on to improve their own software delivery performance. In fact, they've quite literally written the book on the subject. The founders, Dr. Nicole Forsgren, Jez Humble, Gene Kim, they wrote a book based on the aggregated findings of their years of research. It's called Accelerate, Building and Scaling High-Performing Technology Operations. I actually have it right here. Great cover too. Don't judge it by that though. But I think that this book should be required reading for all software engineers, engineering managers, product managers, CTOs, CIOs, and CEOs everywhere. Really, anyone building a business that has any reliance on software, which we've already discussed is most of them, should read this book. It's a fantastic examination of the scientific data and the principles that they applied against those data to inform the conclusions that are drawn from these years of research. Yet today, we don't have time for me to do a whole book reading of the book. I'm sure you'd love that. I wonder if maybe we should have those kinds of meetups in DevOps, just, book club to read Accelerate. But never mind that. Instead of reading the book directly, I want to talk to you about some of the most surprising and most critical findings from the DORA research and the Accelerate book. First, and I think the most surprising thing, is the one that completely debunks the idea of having to make this trade-off for speed versus stability. In the research, they found that high-performing teams, they call them elite performers, actually significantly faster at deploying code, their cycle time, as well as deployed much, much more frequently than the low performers. At the same time, the mean time to recovery of their services when they experienced a production impacting incident was significantly less for those elite performers when you compare them against the cohort of other organizations. This holds true even when controlling for other variables, things like company size, industry, or other firmographic information. So it's not just that the data shows that, some high technology companies are able to move quickly and have more stable systems. It actually shows this happens across industries. In retail, healthcare, manufacturing, government, financial services, you find these same patterns exist. So that begs the question, what exactly are these performers doing better than their lower performing counterparts? What are the measurements here that drive performance? What are the important factors that engineers and leaders should be focused on to improve their performance? Well, luckily for those of us in industry, DORA has been able to answer these questions as well. In fact, they found 4 key measurements, just 4, that both correlate to higher performance and have predictive relationships with both software delivery performance and overall organizational performance. They've found that focusing on the capabilities that enable these allow organizations to measure and improve these metrics. Measure and improve these metrics. Those are directly attributable to how the organization performs overall. So that's like areas of revenue or other organizational goals, as well as human factors like job satisfaction. Improvements in these categories can lead to all of those. It's really a groundbreaking discovery, especially supported by data, because it's really supported by both intuition and the data when you get there. It gives us these 4 key metrics of software delivery and operational performance. And I want to go over each now. These have become known as the DORA 4. So it's worth spending some time to know what each is and how exactly it's defined. Then after it, we'll talk about how to measure and improve these metrics. The first 2 metrics, lead time for changes and deployment frequency, consider the effectiveness and efficiency of the software development process. These 2 are really speaking to the speed half of that pie that we discussed before. And the last 2, change failure rate and mean time to restore services, speak to the second half of the pie, stability. These metrics get at the software deployment processes and their effectiveness in achieving those stability goals for organizations. So let's talk about lead time first. Lead time for changes seems like a simple metric when you think about it. How long does it take for a change to make it through the whole process? But now to measure that with scientific accuracy, the definition must be much more specific than that. In manufacturing, lead time refers to the time between a customer making a request and the time that that request is satisfied. In software development, that's a little bit more complicated by the fact that there's design and product engineering time that goes into fulfilling some, if not all, requests. And then on the other end, when the request is satisfied, can have multiple definitions too, right? Is that when it's in production? What if production means waiting for an app store to publish the new version, or even waiting on the customer's IT team to update the software? So to focus on software delivery performance, this metric specifically refers to the time it takes from code being committed to being in a production-like environment, aka that code is released and ready for production, even if that means there's additional time spent after that point before the customer actually sees the change. If that is, time that the software and DevOps teams don't have control over. Oftentimes in talking with customers, I like to ask, let's say you have one line of code to change or to fix something. How long does it take for that line to get into production? What is every step that line of code has to go through to get there? Asking what seems on the surface to be a pretty simple question like that can actually lead to extremely fruitful discussions about the overall bottlenecks in getting code to production. The other metric that sets teams apart when it comes to delivering better software faster is deployment frequency. How often are we deploying code to production? Again, at first, it may seem unintuitive that deploying code more often, changing things more often, can actually have a positive correlation to system stability and thus overall software delivery performance. Surely going slower and making sure changes to production are slow and infrequent means the system will be better in the end, right? More stable at least. But in practice, that's just not true. And while there are a lot of factors discussed in the DORA reports and the Accelerate book that go into detail about this, I like to force my own intuition to accept it by thinking about deploying to production like a muscle. The more you work out that muscle and build muscle memory, the stronger and better it becomes. So if you find that your team, dreads release or deploy day, or you're scared to deploy on Fridays, the answer might not be to deploy less, but to deploy more. In the end, the top performers are deploying multiple times per day. They've built up that muscle so that deploying on Friday is no worse than any other day because the system they've built has built up resilience and reliability because it has had many at-bats with deployments and testing. And speaking of deploying without worrying, let's talk about how often we do create a problem in production when we deploy or change something. We all know this number, it's called change failure rate in the DORA papers, is never zero. But does your team even have an empirical way to look at this today? Do you know what percentage of production changes cause an issue for your users? Many folks don't track this type of specific data today, and most do these kind of calculations from anecdotal information at best. And even if they are making a conscious effort to track it, it can be next to impossible to really trace the change back through the entire development lifecycle to identify what really caused it to be able to slip through. And because of that, many changes end up, hey, let's close this barn door after the horse already got out. But as with the other DORA metrics, measuring and focusing improvements on this rate shows direct predictive relationships between change failure rate and all the overall software delivery and operational performance of our teams. And finally is MTTR, or mean time to recovery. Again, number of production incidents will never be zero. If yours are, please see me afterwards and let me know how. Because even the largest technology organizations in the world that were born into the cloud and have the best distributed systems engineers in the whole world, they experience incidents. But elite performers and elite performing software organizations work with methods like SRE and SLOs and error budgets to ensure that when incidents do happen, the length of time that they impact users is minimized as much as possible. And they're always iterating on that. So, what do these metrics really look like? How can we measure ourselves against peers in the industry? Well, DORA reports provide the ability to do exactly that. So this table here is from 2019. It's from their State of DevOps report. And while I won't go through everything and every number with you, you can Google it and download the whole report. In fact, you probably should do that. But it is interesting to see the disparity that still exists. Look at deploying multiple times a day versus once every 6 months. That has a huge impact on an organization's ability to adjust to market conditions. Think how quick things change these days. And to those who are able to focus on where they are now on this chart and build measurements to improve, will be able to outcompete their competition in new and innovative ways they haven't even thought of yet. But there's still a problem. That problem is that measuring all of these things can be extremely complicated. We all know if we measure it, we can focus on improving it, right? But today's tooling does not always make it easy to have a clear understanding of even the simplest things, like when did code get committed and when did it get put into production? In a world of disconnected tools doing independent jobs for the SDLC process, it can kind of be like a black box. Code goes in one side, bounces around a bunch of teams and different tools, hopefully comes out the other side into production at some point. If you have many different unintegrated systems that are used, it can be really hard, if not impossible, to understand how to measure these types of metrics, much less visualize them and then make them actionable for your team. To make them actionable, you have to be able to understand where is their wasted time in the process. Often as engineers, we can see this easily, but only anecdotally. We can say, oh, it takes a long time for security to pass a build, or testing takes too long. We haven't had enough time to automate a lot of it yet. But turning these anecdotes into data that anyone at any level can see, from IC engineers all the way to the CTO, is critical in building buy-in from the whole organization to improving the places where time is really wasted. Just as DORA has seen elite performers adapting and improving over their years and years of research, at GitLab, we've seen an evolution in the way teams think about their DevOps tool chains. DevOps is over 10 years old at this point, and we've gone through a number of different phases. These 4 phases are: first, bring your own, then best in class, or then DIY or do it yourself, and then finally the phase we're entering now, the phase of the DevOps platform. In the first, in bring your own DevOps phase, each team would select their own tools. When teams had to come together to create a single product or an application, this approach caused problems when they attempted to work together because they weren't familiar with the tools of other teams, or lacked access to those same tools or the data that those other teams had. I experienced this myself. I was working on a large contract project where the security testing was all done by one person at the end of our 8-week development cycle. And as you can expect, this would often lead to hundreds of new security bugs that now had to be carefully examined to understand their impact, figure out if it was a false positive or something else. And all this while, the engineers had no access to this data or the scanning system before release time, which just led to frustrations all around. To address this problem, many organizations moved to the second phase, best-in-class DevOps. In this phase, organizations standardize on the same set of tools for teams, with one preferred tool for each stage of the DevOps lifecycle. Sometimes these would be tools that allowed for some integration, but often, because it was best in class, it was still a very diverse set of unattached tools. So this phase could help teams collaborate with one another, but the problem then became in moving changes through each of the tools for each of the stages. Those integration points were probably questionable at best, and oftentimes fell on the organizations themselves. So that's what led organizations, especially large ones with lots of software teams, to adopt what we'd call do-it-yourself DevOps. So they would build on top and in between all of those tools. They perform a lot of custom work to integrate their DevOps point solutions together. However, since these tools were developed independently, they never quite fit right. The way different tools look at data points, like the ones we were discussing as being part of DORA research, can vary greatly. And anyone that's ever dealt with a large scale data integration project can tell you what a huge struggle this is. So, and then, many organizations maintaining these DIY DevOps tools, that's a significant effort. Upgrades and changes to each of these tools can easily break the brittle integration points you did have working, or threaten to make the data you had been collecting not able to be compared to current data. So all of this effort actually resulted in higher cost of ownership than if they just stuck with best in class. And worse yet, with engineers spending time maintaining tooling integration rather than working on their core product, where are we back to? We're right back to screwdrivers and servers. A platform approach was needed to improve the team experience and improve business efficiency. In fact, many of these large organizations would refer to their DIY tools that they built on top as platforms, but they lacked the integration that one can gain with a single application, a single data plane, a single place for user role management, and a lot of other benefits you get from a single application. That's where GitLab, the DevOps platform, allows organizations to replace their DIY DevOps, allowing for visibility throughout and control over all stages of the DevOps lifecycle. And we're seeing other DevOps tools teams come to the same conclusion and then try to play catch up with what we've been building as the industry shifts into this new phase. The DevOps platform lets you realize all of those benefits we've been trying to solve for since we invented the word DevOps. After all, DevOps was supposed to represent merging developers and operators together. And then you hear people these days say things like DevSecOps or DevSecBizOps. And those sound really buzzy, but those phrases have, some truth behind them. As we've seen already, companies' very business survival depends on their ability to ship software. And to ship better software faster, you have to be able to control, measure, and understand how your teams are building that software. Bringing teams together can't just be a catchphrase. It has to be the reality of the operating model of our organizations. Without that, we'll never understand and realize the real promise of DevOps, right? And in much more practical terms, that means moving teams to using the same tools, the same platform, to optimize not just for team productivity, but for cycle time, for deployment frequency, MTTR, and for reducing the change failure rate. By empowering all of the teams, software, operations, IT, security, and the business to collaboratively plan, build, secure, and deploy software across a single end-to-end unified system, GitLab represents a fundamental step change in realizing the full potential of DevOps. The DevOps platform is a single application powered by a cohesive user experience, agnostic of being self-managed or SaaS deployed so that you don't even have to think about it. But it's built on a single code base with a unified data store, which allows organizations to resolve all these inefficiencies and vulnerabilities of unreliable DIY tool chains. And to top that off, it isn't its own black box. By building our company and our software in the open, you gain the increased knowledge of millions of other practitioners coming to bear on these problems. And being built on open source, everyone can contribute to this next phase of DevOps and to the DevOps platform directly. Thank you so much for coming today, listening to me speak, and I hope that you learned something. If you take nothing else away from the talk today, I at least hope I got you thinking about your own team's performance and how metrics like the DORA 4, which are backed by scientific evidence, can help your team improve over time. Or even if you just learned about Accelerate the book and added it to your cart to read later, that would be enough. I'll be around afterwards to talk about the talk and any questions you have, or if you could share experience that you have that run counter to any of the examples I've talked about today. I'd love to hear about that. After the conference, the best place to find me is on Twitter. I'm at O'Leary Crew, all one word. My DMs are wide open, and you can follow me for a healthy balance of tech, snark, and probably a lot of Taylor Swift quotes.
All right. And we're joined live with Brendan. Brendan, we've been getting a lot of love on the Discord over there. Seems like people have really been enjoying. Some of them are learning about DORA for the very first time. So some pretty good energy here. They've been asking some questions, and I thought to get as many of them in as possible within the Q&A session.
Yeah, that'd be great.
Let's just get this going here. So first up, what are your thoughts on giving developers more hats to wear, like making them also manage DevOps?
Yeah, it's a great question. And I think it's something that's happening, right? Like, so you can't ignore the fact that it's happening. That's probably, the question kind of even is peppered with that, right? But is that what we should do? I don't know. I think the idea of bringing the word DevOps together was, developers should be able to think more about what it means to operationalize software, but it also means operators should be able to think more about what it means to develop software and be doing things as code, right? And so really what it should mean is bringing the best of both worlds together, right? The ideas behind SRE and, operating systems and distributed systems and all those things, those should come, and flow down to developers, and developers should be able to understand more of that, and vice versa. So in reality, though, a lot of folks hear DevOps and they're like, okay, now developers are responsible for operations. I don't think that's the right choice. I think there's still, a discipline of system reliability engineer that needs to be, part of a successful team. But hopefully the DevOps methodology can bring that team together with developers, so it's not just throwing code back over the wall between the two.
Right. Along those lines, so DevOps metrics. DevOps metrics is one metric more important than another, or are they all equal?
Yeah. So I actually I saw that question and I broke out my book. I'll show the book off again, and I was like trying to frantically look up the science, like if there's a scientific difference in the correlation. I didn't find it. I might tweet at Dr. Forsgren later and see if that's true. So I'm going to give a non-scientific answer is the lead up there. I don't think that there's one that's necessarily significantly more important. I do think that lead time is the one that I start with people, because I think it's the easiest to kind of gronk. If you're not doing anything with metrics today, it's like, how long, I've got one line of code I want to change. How long does it take for that line of code to get into production? And what are all the steps that it takes to get there? Right. I think that's the one that I would focus on first. But that's not from a place of science. That's from a place of anecdote. So it would be interesting to know if there's a stronger correlation, and that may be buried in the report of the book somewhere, but I couldn't find it in my brief.
I think that's still pretty helpful, especially for folks who are still new to DORA. I think getting your take on that will help lead them in the right direction. Next up, we have a question by Josie from Discord. And they ask, what is the real cost of trying to look at everything using DORA?
Yeah, so I think there's a couple ways to look at this. I think traditionally we've been really bad as an industry at measuring effectiveness, right? You've seen people like, oh, I'm going to measure the number of lines of code that someone commits, and like there really couldn't be a worse measurement probably for software development. And so I think there's a bigger cost to measuring nothing than whatever the cost is to measuring something. Now, the DORA 4 really talks about your software delivery performance. And I do think that ties directly, and they do have evidence in the research that ties directly to organizational performance. So you could say that, in theory, that's the be all end all, according to that research. But, of course, things like, the growth of your business or the satisfaction of your users that your users have using the software. Those are the kinds of things you should measure as well. But if you're trying to, if you're an engineering manager or you're on a team that's struggling to understand what does good look like for a software team, it's a great place to start. And then the cost can be high depending on, if you are able to easily answer those kinds of questions, right? So I think that's why we're seeing this kind of consolidation in the DevOps kind of tools industry towards DevOps platforms, where you have more and more things happening inside of a single platform. The reason for that is folks want to be able to see from start to finish, what their DevOps lifecycle looks like.
So I'm so glad you made, of course, the book Accelerate is foundational to your talk.
Mm-hmm.
Looks like we had a question. Remember, the author had a section about surveys, internal surveys. Do you have any recommendations when it comes to surveying teams, maybe how to structure questions? Anything you can comment on there?
Yeah, sure. There's an entire chapter on it in the book. So I would definitely recommend reading that because, again, Dr. Forskens knows way more about it and has studied it and is a PhD in these kind of human factors and surveying and how to get the right things out of survey data. Talks about, what are the right things that survey data is good at measuring, how to look for bias in surveys and avoid it. And then, a lot of other things like that. So I'd recommend digging into that. But I think the most important thing that they bring up in the book is that, there are some kinds of things like employee satisfaction and how, if they feel empowered in their role, if they feel like they're able to, change and enact change in their day-to-day, those kinds of things are really only found through surveys. So that's what makes it so important to have, some level of surveying to understand what's going on in an organization.
If I recall from that chapter in the book, I think what I liked most about it was that it measured the degree upon which someone agreed or disagreed of a statement like, I feel that my team is listens to me and gives me feedback, right?
Mm-hmm.
Because even though each person might feel, they might think of a certain number differently than, say, one of their peers, I think you eventually kind of get the overall sense as to what, yeah.
Exactly.
So that's one thing I appreciated there. So next, we have a question from David. Did I see on the DORA site mention of a fifth metric, the ability to meet or exceed reliability targets?
Yes, so there is this fifth metric that they kind of differentiate from the four. And so I did, simplify the talk by not bringing that into it. But yeah, it's this kind of bringing the concept of SLOs and reliability targets into this world. And I think, I don't quote me exactly, but I think that the correlation is different than with the other four. And so they talk about that not as part of software delivery and operational performance, but as part of overall application performance. I can't remember exactly how they put it, but there is a fifth metric that they really started measuring for the last like 2 or 3 years versus the other four they have data on going back the 7 years. And so it will be interesting to see that the next report is coming out sometime in the end of this year. What more they've learned about that.
This makes me think of a question. I don't have a card for it, so I'll just ask it. How have you seen teams put together the measurements? I mean, is it just really an Excel spreadsheet that's shared with people, or is it some sort of dashboard, or are there tools right now that help facilitate that and visualize it for people?
It's a great question. And so, yeah, I've seen a lot of different implementations of it. Some of them take, basically the DORA survey. If you have a large organization of, 1,000 or more developers, they might be doing the same thing DORA is doing, but just internally, right? Which is surveying folks to understand, what do they think? How do they think they're performing? How do they think their teams are performing in these metrics? But we're seeing a huge push towards, the ability to actually measure with, some accuracy. In theory, you should be able to measure with some accuracy, what these things look like. And so when it comes to each of them, though, the problem can be that, there's a different tool for each metric, right? Like our MTTR might be in some tool our SRE team is using, but our, lead time for changes might might be in some tool that our developer team's using, or it might really be the combination of time spent in a bunch of different tools. And so I think that's kind of goes again to that developer or DevOps platform that we're seeing. It's something that we're focused on at GitLab. And so we've actually got a section of GitLab where you can find some of these measurements today if you're using GitLab. And we're very focused on how we can help teams, measure this kind of more accurately.
When it comes to teams who are, again, this one's just inspired a follow-up question for me. Yeah. When it comes to teams who are trying to implement this, what would be your recommendation for striking that balance of, because you are measuring potentially either a team or maybe even down to the team member, there might be some big brother accusations sometimes from those individual developers. How do you encourage teams to strike that balance, or what have you seen has been a successful way of it, working around that or through that?
Yeah, no, I think and even in the book they talk about this a lot, where it's like it's not necessarily some absolute metric that says you are better than me or I'm better than you. It's really metrics that are meant to be used by teams to understand kind of where they are and then how they can improve. And so I think that's a key thing to keep in mind, right? Like it's not a metric that should be used to, decide who's better than who. It's a metric that should be, designed to find areas for improvement. And so that's tough. I mean, I think this is just, true in business in general, that you have to be careful about the metrics you use and what you use them for and how you apply their use. And, if you do that in a way that's, seen as punitive or negative, like you're going to drive all kinds of weird behavior you don't want.
Yeah.
And that's just kind of a rule for life. Yeah.
Completely agree. Looking at the Discord, it looks like you have a little shout out. They love the pink magenta GitLab pin.
Thanks. Yeah.
It's subtle. Very shiny, very subtle, but yeah, very easy to miss as well. I love the notes, the repetitive. I like the color repetition that you got in the the neon lights behind you. We do have one for Funzy question. Looks like there was a lively discussion about monitors in the Discord. Can you ever have enough monitors?
Yeah. So I have got two answers to this question. One was my funny answer that I put in Discord, which is I also fancy myself an amateur woodworker. And in woodworking, they say the number of clamps you need is always n+1, being like where n is the number of clamps you have now. So you always need one more clamp than you have. So I think that's kind of fun to apply to monitors. I'm currently sitting and looking at like 3, but I recently got one of those ultra wide monitors. And so now there's like a whole debate of like, do I have one big monitor or many small monitors? That is number of monitors is probably also like tabs and spaces. You can get 3 engineers in a room and get 7 opinions about what the right answer is.
The debate will rage on, I'm sure. So as we hit the top of the hour here, Brendan, I wanted to give you an opportunity to give us any final thoughts you have on anything that you want to tell our audience.
Sure, thanks. Well, like I said, I think that we're going to see this evolve. If you've just learned about DORA for the first time, go get the book and read it. It's fantastic. Look for the latest DORA reports coming out soon. GitLab's actually a sponsor of that as well. So we'll be having some messaging coming out around that. And then you can find me on Twitter, like challenge me, the things that you find not working for your team that I talked about today. I'd love to hear from you. I'm at O'Leary Crew and I'm available. So I'd love to hear from everyone.
All right. Thank you so much, Brendan. I really appreciate the talk, and thank you so much for being a part of GitKon.
Yeah, thank you so much for having me, and thanks for the conference and the fantastic work that you all do. Really appreciate it.
You got it. You take care.
Yep. Bye-bye.